Today we're going to talk about another tool that we can use to solve quadratic equations, and that's called completing the square. So to warm up, I want to look at these problems here to factor, and I want you to notice that these are all perfect square trinomials, where the C term is a perfect square and the A term is a perfect square. And what that allows us to do is it allows us to write our quadratic in that form, and then we can solve it using the square root properties. So let's look and factor these. You have a perfect square here in 36, a perfect square in here, a 1. So we can write this as minus 6 squared, and we know it's going to be minus because your b term is negative. For number 2, we're going to have h plus 2, again, because our b term is positive, it's squared, and the square root of 4 is 2, and the square root of 1 is 1, that invisible 1 in front. Now, number 3 doesn't have an a value of 1, but it's still a perfect square trinomial. Your a term is 9, and your c term is 4. There's going to be 3x minus 2 squared. Again, it's minus because of that. So doing this quickly will be very useful when we do completing the square. So now down here, we're going to solve using this. We have our a value 1, our c value is 9, so that's a perfect square trinomial, and we can write that as x plus 3 squared, and that's going to equal 36. Then we're going to square root both sides, and we get x plus 3 equals plus or minus 6. Because remember, the second power and the square cancel off. So we have x plus 3 equals negative 6, and x plus 3 equals 6. Once we subtract 3 from both sides, we have x equals negative 9, and x equals positive 3. And those would be our two solutions. In example 2, again, we have a 1, which is a perfect square, and a 16, which is a perfect square. So that's going to give us 4x minus 1 squared equals 9. And again, it's minus because our b term is negative. If we square root both sides, we get 4x minus 1 equals plus or minus 3. So 4x minus 1 equals negative 3. 4x minus 1 equals positive 3. Over here, we're going to add 1 to both sides, so we get 4x equals negative 2. And when we divide both sides by 4, we get x equals negative 2 over 4, or negative 1/2. Then the other solution, we're going to add 1 to both sides, so 4x equals 4. Divide both sides by 4, and we're going to get x is equal to 1. So those would be our two solutions for this problem. So now, what happens if we can't factor using that perfect square trinomial shortcut? What we can do is we can create one, and that process is called completing the square. And I'm going to go through these steps as I'm doing these problems. So example number 4 down here, we have 1x squared plus 20x equals negative 19. We want to make sure that the a and b term are on the left side, or one side of the equation, and your c term is on the other side. Then what we're going to do is we're going to take our b value, which is 20. We're going to do 20 divided by 2 squared, which is equal to 10 squared, or 100. We're going to take that 100 and add this to both sides. And we can do that because we're just adding the same thing to both sides. It's not going to cancel anything off. And that's what people get confused about. Is like, well, why can't we just add 100 to both sides? We're not getting rid of anything. We can do anything we want to equations as long as we do it to both sides. Now, the left side, we have a perfect square trinomial. 100 is a perfect square, and 1's a perfect square. So we have x plus 10 squared equals 81. Then we square root both sides. We get x plus 10 equals plus or minus 9. And then our two equations are going to be x plus 10 equals negative 9. And x plus 10 equals positive 9. And when we solve these, we're going to subtract 10 from both sides. X equals negative 19 and x equals negative 1. Those would be our two solutions. So you can see that completing the square can be quicker in some instances. This did not take us much time at all. In example 5 right here, we do not have ax squared plus bx. We have a c term there, but it's equal to 0. That's telling me, do I want to factor? Well, I don't think I can factor this problem, so we'll skip that. And we'll go to completing the square. Subtract 1 from both sides, we get x squared minus 10x equals negative 1. So then I take that b value of 10 divided by 2 and square it. So then we get negative 5 squared, which is 25. So we're going to add 25 to both sides. The left side is going to become x minus 5 squared equals 24. As we get when we factor that. One thing you might have noticed is, right here, we did negative 10 divided by 2, we got negative 5. It's x minus 5 squared. Over here, we did 20 divided by 2, we got 10. It was x plus 10 squared. So this number here will help us in factoring. So x minus 5 squared equals 24. Square root both sides. We get x minus 5 equals plus or minus the square root of 24. So we need to simplify the square root of 24. When we simplify the square root of 24, we get 6 times 4. Actually, I'm going to write that in reverse. 4 times 6. And then we can simplify the square root of 4. And we can add 5 to both sides if we want. So x, or we need to, equals 5 plus or minus 2 times the square root of 6. And that would be your final answer. With this one, I noticed that my a value isn't 1. So that means something's got to change. If we subtract 100 from both sides, we get 3x squared minus 36x equals negative 150. So we're going to divide everything by 3. And what that is going to get us is going to get us 1x squared minus 12x equals negative 50. Now I can complete the square. My b value is negative 12, so negative 12 over 2 squared equals negative 6 squared, or 36. We're going to add 36 to both sides. Oops. All right. Then on the left side is going to be x minus 6 squared, and on the right side, negative 14. Now, you're going to notice that we're going to take the square root here, and if you try to use your calculator, you're going to get a wrong answer. It's going to tell you that there's no real solution, and they're right. There is no real solution. But because we know the imaginary number, I, we can go forward. So x minus 6 equals plus or minus the square root of 14i. Because negative 14 can be broken up into positive 14 times negative 1, and the square root of negative 1 is I. Now we're going to add 6 to both sides. We're going to get x equals 6 plus or minus the square root of 14i. And we can leave our answers just like that, and we'd be done. On the next page, I want you to try these two problems, letters A and letter B. When you're done, unpause it and see what we get. Okay, so here are the answers and the work. So hopefully you got these answers, but if you didn't, you can look at the work that I showed and get those, get those questions clarified. So when determining which method to use to solve these quadratic functions, there are some things we want to look for. When we're solving by factoring, we want the equation to equal 0, and our a value, we would like it to be 1, but we can also factor if our a isn't 1. So one of the equations that could be solved by factoring would be x squared minus 3x minus 4 equals 0. We can't do really completing the square with this one because our negative 3 is an odd number. If we're going to do completing the square, we want our b value to be even. But we can factor this. Two numbers that multiply to negative 4 but add to negative 3 are negative 4 and positive 1. So we could factor that and be done very easily. When we are solving by square roots, we want an equation that doesn't have a b value. So 5x squared equals 80. That would be a good one to solve by using square roots. And then finally, by completing the square, we want one that is not factorable, and our a value is 1 and our b value is even. So if we had maybe x squared plus 4x equals 17, that won't be factorable, and we can solve that by completing the square, and the other methods just won't work as efficiently. What we're going to be doing today is using the completing the square technique to convert our quadratics from standard form into vertex form. Remember, in standard form, we have y equals ax squared plus bx plus c, and your vertex form was y equals a times x minus h squared plus k. And we said that they both have the same a value. So one of the ways that we did this was with standard form, we did negative b over 2a, and then substituted that value into our function for the y-coordinate of the vertex. And then, that negative b over 2a gave us the x-coordinate. The substitution gave us the y-coordinate. So then we took a from standard form and then the h and k and made vertex form. So that can be a little bit time consuming. So we can do the completing the square technique, because remember, when we complete the square, we create a perfect square trinomial, a number plus or minus, x plus or minus a number, that quantity in parentheses squared. Well, that would be your h value, and then whatever number we added to the outside would be your k. So write the quadratic function in vertex form by completing the square, then identify the vertex. So remember, when we complete the square, we take our b value and divide it by 2 squared. Well, negative 10 divided by 2 is negative 5. Negative 5 squared is positive 25. Now when we completed the square, so let's do y equals, when we completed the square yesterday, we would take that 25 and add it to both sides. And you see, well, there's no both sides here. Everything is just on one side of the equation. So what we're actually going to do is we're going to add 25, but we're also going to subtract 25. Because this right here is really equal to 0. So I didn't change anything in the equation. And then remember, we had this plus 22 right here. All right, so now I'm going to factor this. And remember, that's going to factor to x minus 5 squared. Because of this negative 5 we got up here, it's going to be minus 5 down here. And then we can combine our like terms here. This negative 25 plus 22 is negative 3. So our quadratic is y equals x minus 5 squared minus 3, making our vertex positive 5 comma negative 3. So with this next one over here, okay, we're going to do our b value, 18 over 2 squared, which is 9 squared, which is 81. So I'm going to add and subtract 81 from the right side. So y equals x squared plus 18x plus 81, and then also minus 81 plus 95. This factors into x plus 9 squared, and then negative 81 plus 95, that's going to be positive 14. So then our vertex is negative 9 comma positive 14. All right, then this one, our b value is negative 4, so negative 4 divided by 2 squared is negative 2 squared, which is positive 4. So x squared minus 4x plus 4 minus 4, and then we have that minus 1. So this will factor into x minus 2 squared, and then our combining like terms here, negative 4 minus 1 gives us negative 5. So that makes our vertex positive 2 comma negative 5. All right, so thanks for watching. Make sure to like the video and subscribe.